Now, while Unreal Engine has a built-in way to do depth of field through its cinema cameras and some post-processing stuff, I actually like making my own post-processing material to drive a lot more custom depth of field. Now, before we get into any of this, there is the slight caveat that doing this through your own post-processing material, while it gives you a bit more control, and I think in a lot of ways actually makes your depth of field more intuitive, it also has the potential to be a lot more computationally expensive than using the very optimized built-in depth of field. So just don't go crazy with the numbers in the scale and the quality that we're going to be working with here, and you should be good to go. So let's dive into a empty project. The finished project, of course, as always, will be down below in the description for YouTube members and patrons to play around with and just download as is. We're going to make a new post-processing material here. I already pre-made it here in the start of the video. In that, we set the material domain to post-processing, obviously, because it's going to be a post-processing material. Now, don't get scared, but we're going to be making a custom node here. And the reason that we make a custom node is because we're going to need to be able to loop through different pixels. If you just want to set this up as a one and done, this is the size of our blur, you don't need to do this as a custom thing at all. But the thing is, we're going to want to have different sizes of blur depending on the distance from the camera that we are. Meaning that we need to do a for loop with a couple of variables in it to actually drive how blurred any given pixel is going to be. Before we dive into the actual code, a real quick overview of what we're going to be doing. Because what is blurring a pixel in general? Well, a very quick, somewhat oversimplified overview is what you do is you take the color of any given pixel and average it out with the colors of its neighboring pixels. So if you just take one pixel and look at the 8 pixels around it, take its average color and do that for every pixel in your image, you get a slightly blurry image. If you want it to be more blurry, what you do is you expand the searching area out to average out more colors, more pixels, and as you can probably guess, that quite quickly becomes a lot more expensive to do, especially in a real-time thing like a game. So we're going to split things out a little bit between two different values. We're going to have a quality value, which is effectively how many pixels we sample. And we're going to have a size value, which is how far along we check those pixels. If you set the size to a super big number without the actual quality being a big number, it's going to be a little bit ugly, but it is going to still be a big blur. Ideally, you would just sample each pixel in your entire size, but that's going to really impact your performance super quickly. So back with the custom node here, what we're going to do is first we need a couple of inputs. So if you select your custom node, you can come over here to the inputs and we're going to give these names. So the first input is going to be our scene color texture. Then we add a new input through adding this element here, and that's going to be our UVs, just our viewport UVs really. Then we add in a quality, and we'll also add in a size. These are all going to be values that we're going to be giving in a moment. The output obviously is going to go into the emissive color. It's going to immediately complain at us because some of these don't have values, and the custom node does require you to put in values. So let's give those in. The first one is going to be a scene texture, and we're going to give that post-process input 0 as its input. The second one is going to be our screen position, and we're going to input the UVs from that. Then we set our quality. I'm just going to set this to a quality of 2 for the time being, but the higher this is, the more detailed our blur will be, but the more expensive it will be, obviously, to run as well. And then I'm also going to put in a size, and that size is going to be, let's also do 2 for the time being. You'll notice that it stops giving us an error, and it actually outputs what we see here, a float 3 with 111, which is pure white for every pixel in our viewport. Hey, if you're enjoying this content and it's helping you out, please don't forget to leave a like on this video. You can also leave a comment on this video expressing what you liked or asking questions that I can cover in future videos. And then of course, if you want to stay up to date with those new uploads, make sure that you're subscribed to the channel as well. And to get started here, we add in a const integer, which will just be our scene color ID. This is a little bit weird. You might imagine that just taking our post-process input 0, I will fix this up in a moment, would just give us the pixel colors that we put in. It doesn't really do that. We're going to need to actually sample within this custom node, but for that we need to have the ID of which channel we're sampling from. And post-process input 0 is just that. It's the 14th. Anyway, it starts screaming at us, which is immediately a good point to point out that writing these custom nodes is a little bit annoying in that this is not a proper IDE environment or whatever. So number one, your errors are going to be kind of bad. And number two, you're not going to have any like good indentation or whatever. So generally, it's a good idea to just kind of click off after every line or every couple of lines that you write to see if you get an error. Because you don't want to write out the full thing and then get a bunch of errors that are really hard to actually debug. Right here, what we actually have is that we don't have a proper return value. Apparently, I accidentally deleted that. So we need to return that float, and there we go. We also need to have a semicolon. Before we can do anything with the colors, which is the fun part, we need to do a bunch of stuff to set up the UVs. The UVs are a little bit weird because we want to be able to take in variable squashing and stretching and whatever, but that shouldn't impact the shape of our blur. So UVs usually are just a value from 0 to 1 in both the X and the Y direction. But if we just use that, then it's always going to assume that our viewport is square-sized. And if our viewport is then rectangular size, which most of the time it will be at like a 16:9 or 16:10 aspect ratio, is going to actually make our blur, instead of circular, it's going to make it a stretched ellipse, and we don't want that. So we need to do a bunch of math here on some like viewport size with UV and whatever. So we'll go through that relatively quickly, and then we can get to the fun stuff, which is looping over all the color stuff. So let's make a comment here. UV protection is what I just call it. So what we do is we make a float2, and we'll call that something like scene UV. And we'll make that up of a like little string of code here. That's going to be view.view rect min. And to that, we're going to be adding our UV multiplied by view.view size and inv size dot x and y. And that we then once again multiply by our view dot buffer size and inv size dot zw. And I noticed that it's all off screen, so I'll make sure that you can see it all actually. Make sure no stuff is accidentally capitalized when it shouldn't be, and then that is the line of code that we're doing. So effectively what we're doing here is we're normalizing our UVs to our screen size. So if we have a wider size, our blur isn't getting stretched out in any kind of weird ways. Then we also make a float2 for a texel, which is going to be our view.buffer size and inv size again, .zw, and we multiply that by our input size. Now we need to set up the minimum and maximum UV positions so that we know, mostly for clamping purposes in a moment, so that we don't sample outside of what's actually on our viewport, because that's going to make weird glitchy edges to our screen. So we make a float2 for the UV min, and then a float2 for the UV max. And the UV min is going to be equal to view.view rect min. And again, make sure there's no typos in that. And we're going to multiply that by our view buffer size and inv size .zw. And then for the UV max, we're going to do something similar, except we're going to put these within two little parentheses, and we'll do view dot our view rect min, and this time we're going to add our view dot view size and inv size dot x and y, not zw. This one is x and y instead. And then we multiply that still with, after I change this to not be mistyped, we still multiply that with our view buffer size and inf size.zw. All the same. So effectively what this is we get the minimum UV position, we multiply that by the actual size of our viewport, and then we get our minimum viewport position for the UV. Then we add to that the size of our viewport, so that's the max UV, and then again we multiply that with the actual viewport size so that everything is consistent at different sizes. Again, click off to see if I made any mistakes in typos, and it seems like I did. Inf size is with a capital N, shouldn't be. Also want to call this UV max and put down an equal sign. And I forgot a dot here between view and buffer size in both of these. So now those errors are fixed. Again, make sure you regularly go over and check the lines that you just wrote, because otherwise it's going to be a pain to fix up. Now, all the UV stuff is done, so we can start with the color stuff, which is the fun bit, right? So we start off by making a float 3, which is just a representation of a color, and that'll be the center color for the pixel that we're currently sampling. So just for a bit of context, everything that we're writing here, it's going to do all this code for each pixel on your screen. So this center color is the center color of the pixel that we're currently working on. So we're going to sample that from our texture. So scene texture lookup, there we go. And we'll take in our scene UV, our modified UVs for that. Then we'll take in our scene color ID, which you might as well just put in like the number 14 here. Would be kind of the same. And then we put in false. And we mask that in the RGB because we don't really need the alpha from it, since we're not using a normal texture. We're using like your viewport, which is not going to have an alpha. So we don't give it an alpha. Now, before we move on with the looping and sampling of neighboring pixels, we want to check whether or not our quality or our size is 0. Because if either of those are 0, the blurring effect isn't going to work properly. So what we want to do in that case is we want to just return the pixel that we're sampling more or less unchanged. So we check if our quality is less than or equal to 0, or our size is less than or equal to 0. Or alternatively, what you could do is you could just check whether or not the quality or size is less than 1, because you do still have the issue if these are very tiny numbers, they still get a little buggy. So what you can do instead is you can actually check them against something like this, which is effectively checking, hey, are you under a value of like 4 decimals? So 0.0001 instead. That way you catch a little bit more than just exact 0 values. Just whatever you prefer, honestly. If that is the case though, if we're not going to be blurring a pixel, that's effectively what we're checking here, is do we need to blur this pixel at all? If not, either way, if that is the case, we can simply just return our center color that we just sampled. And now we'll see if I set this value, one of these values, to 0, it actually just returns the original value. And if both of them are over 0, it returns 111, just because that's what we're returning at the moment. We're working towards actually making that a blurred version of our image. So let's say check if should blur as a comment. And then we finally set up our 2D kernel. Now here you can do a lot of creative stuff. We're just going to set up a simple circular kernel, which is what a general like Gaussian blur would be. But you can do a somewhat simpler version of setting up a kernel, which would be a box blur, which just samples the pixels around it in just a square or rectangular shape. You can even put in a low resolution texture here and sample like a mask from that texture if you wanted to. You can really like knock yourself out. This is part of the reason that it's nice to have your own post-processing, because you can do fun stuff with this. For now though, what we're going to do is we're just going to make a float 3. We'll call that sum, set that equals to 0 for now. Then a float w sum, which will be equals to 0 as well. So equals 0. Then we make another float, which will be our inv to sigma 2. And that will be equal to 0.5 divided by our quality squared. And I think there should actually be... Hold on, we have a quick cut in here during the editing process in a couple of places throughout this tutorial. When I say square, I actually type out sqrt, and that is entirely my mistake. I overlooked the fact that this is square root and not squaring, so it's the opposite of what we actually want to do. So what you want to do is, instead of using sqrt everywhere that I use it, you just multiply the variable by itself. There is no dedicated square function in the shader language, apparently. So this is just the way that we square numbers instead. Now we're still working with floats and all that kind of stuff. Since we're actually sampling specific actual pixels, what we want to do here is we want to eventually turn this down into a float. And that float we're going to just call R2 for now. And that will be our size that we give in here, squared. So we'll do, again, sqrt for the size. And this is all the information that we need to set up our sampling around each pixel. So now it's time to write our for loops. So what we're going to do is we're going to write 2 loops nested. So the first one is going to be for the y direction, and then the other one is for the x direction. So what we do is we check our int dy, just the sampling in the y direction. And we're going to start that off with being the negative of our radius, which is our quality multiplied by size. So actually, it's probably a good idea to change a couple of things around here. Make float radius at the very top, which will be quality times size. And then this R2, instead of using size here, we're going to square the radius itself. And then we can just use radius going forward here. So int dy equals negative radius, semicolon. We're going to check if dy is still less than or equal to the radius. And then we're going to plus plus dy. No, plus plus, not equal equal. Plus plus dy. So this is going to loop over our radius from left to right. So we have a single pixel. We're going to start with it being left of that pixel, and then we're going to move along until we're equally to the right of that pixel. And then we put our code into some brackets. We're going to copy over this for loop, and I'm going to just manually inset this a little bit with a couple of spaces, because again, we don't have like indentation for any of this, which is kind of annoying. And here we're going to change all of the y's to x's. So we're going to make dx, dx, and dx. And this essentially is just going to check around us now inside of a box. So if you're making a box blur, we would sample every single one of these pixels. But since we're not making a box-shaped blur, but we're making a circular blur, we need to write a little bit more code to make all of that work. So let's do that. So we'll make int d2, and that will be equal to our squared dx plus our squared dy. And then we want to check if our d2 that we just made is now greater than our r2 variable that we made outside of the loop. Because if that is the case, we are outside of the circle that we're checking. So we're checking every pixel in a box. But before we can actually sample those and add those to our total, we need to check whether or not the pixel that we're sampling is also within the circle that we're going to be checking. And that's what this is doing. This says, hey, if your D2 is bigger than R2, that means that you are outside of the circle that I actually care about. So continue on to the next iteration of the loop. Then we make a float for W, and we'll make that a exponent of minus float D2 multiplied by inv to sigma 2. For some reason, I called this float 2. You want to call this float W. I just mistyped because I'm looking at my reference project because there's a lot of code here. The next thing that we're going to be making is a float 2. So that's just a mistyping on my part. And we'll make this UVT, the UV for the actual texture that we're going to be sampling, which will be our scene UV that we made up here. And to that, we're going to be adding our float 2. That's going to consist of our dx and our dy. So that's the actual specific location in our scene texture that we're going to be sampling right now. and we'll multiply that by our texel. All right, now we do want to make sure that every pixel that we're sampling, we're clamping that to the edges of the screen. So if there is a pixel that we're sampling very near the edge of the screen, and it would try to sample anything outside of the screen, that would end up being like weird and glitchy and whatever. So we're just going to clamp any sampling that's trying to do outside to the very last pixel that we can actually find. So for that, we want to take our UV for the texture, and we want to clamp that, the input value being the UVT, of course. Clamp is actually without a capital C. And we want to clamp that between our UV min and our UV max. So we can just copy those variable names over, making sure nothing gets typoed. And now that we have all of that, we can confidently say, okay, we can now finally sample the color of the pixel that we're going to be looking at to use for blurring our like main pixel. So we call this float 3, and we'll call that something like the sampled color, which will be a scene texture lookup. Again, making sure that you guys can actually read everything. And we'll use the UVT for the UV to look that up with. We'll still use the scene color ID that we declared here above. Again, you can kind of just put in the number 14 there if you want to. And then we also put in false. Once again, masking this in the RGB channels. Now we have that color, and we come back to this. We have this sum and this W sum, which started as 0, just entirely black. Inside of this loop, we're going to be adding to those values. So what we do is we do sum plus equals our sampled color times W. And again, I'm just going to add in some spaces here. And we'll get our W sum, and that's just going to plus equals W directly. Now, after this entire nested loop is done, we'll have sampled all of the pixels around the pixel that we're currently working on. So these values will be, number one, just huge, right? They'll be way beyond a value of 1. So we need to divide some stuff. But this gives us the potential average color of the pixels that we're working with. So let's actually construct that value. Float 3, we'll call that blur, and we'll make that equal to our sum divided by the maximum between the W sum. The W sum is just there to keep track of how many things we have sampled, and there's some weighting in there where things on the edges are weighted a little bit less strongly so that you have a nice like smooth fall off. We make sure that there is a maximum between the W sum and like this value here. And then what we return is just that. So instead of making that a variable, we can just actually just set that as the return for each pixel. And with that, we can see we have 2 and 2 in the quality and the size, and everything is now entirely blurred. Now, it's not entirely accurate to call this quality because this also contributes to the blur size. As you'll see, if I put this up to like 10, we get a super blurred thing. But the thing is, what it's doing here is actually sampling more pixels out. Whereas if we do it the other way around, we set this back to 2 and this now to 10, it is sampling more far spaced apart pixels, meaning that this actually like increases the size of the blur without increasing the quality. So what you'll probably want to do is make a float in here, and that is like actual size. And we'll set that equal to our size divided by our quality. And then everywhere where we use size, if you replace it with actual size, that should improve things significantly. So I think we only use size in the texel thing. So now you'll notice that if I increase this to 15, it doesn't actually increase the size of the blur. Set it back to 5, but if I increase this, it increases the size of the blur. And then if I decrease this, it's literally only going to impact the quality of the blur. So that's a nice little addition that we have here. But this now just makes a blur everywhere. Everything is blurred. So this size obviously is going to need to be driven by some sort of Z buffer depth. So let's get rid of this as an input. It's going to error out because it's now missing an input. We'll get back into that in a moment. copy over the scene texture, and instead of post-process input 0, what we're going to do is we're going to find the scene depth. So that is this. We're going to mask that in the R channel because we only need a single component out of this. And if we just put this in now, you will see that it might crash. Okay, so after the crash, the reason that we had a crash there, by the way, most likely is because it was giving in huge values through the scene depth into this, which it isn't really supposed to. So before you put in your scene depth, you probably want to add in even just a simple clamping node. But of course, we're going to do more than just clamping because we want to turn this blur into a depth of field effect. So what we do is we add in back our scene depth, but now before I put it in, we still mask it in the R channel, but I'm going to clamp it just to show you. So clamp that between, let's say, 0 and 10. If we then apply that and save that before it crashes again, we put that into the size. Now it doesn't actually crash, but as you can see, the closer I get to it, at some point it does become sharp. The issue is that the window in which things are actually sharp, the focus plane, is only a single unit big. And there's no fall off that gives any leniency there. And this is where using our custom solution rather than a built-in one gives us more control, because we can extend this focus plane into a focus field. Usually a real camera has technically only one place that ever is fully in focus. Everything else that looks sharp just doesn't get blurred enough to really noticeably be blurred, but it still technically isn't 100% sharp if it is outside of that plane. We can actually code this to only start applying blur if it is a certain distance away from our desired focus point. So what we do is we do a couple of things here. We subtract a value. So subtract, for now it's going to just be a scalar, let's say 100. This is going to turn into a parameter that we can set for the player's distance. Then we take the absolute value of that. So this effectively creates a gradient that will be the distance from that point in our scene depth. So if we set this to 1000, what we end up getting is everything that's closer than that 1000, or 500 because it's half of it technically. Everything that is closer than that 1000 is going to have a increasing value, and everything that is further away than at 1000 is going to have an increasing value. So we just offset the 0 position with this, essentially. Then we also subtract from that a new parameter. Again, we're going to change these into parameters in a moment. And that's going to be our focus window size. So how much to either side of our focus point are we going to want to be in focus? Again, I'm going to set this to 100 for now. Then we take the max between that and 0, because we could very well be subtracting things below a value of 0, and we don't want that because we're going to be putting that into our size here. And that expects a value of a positive magnitude. Then I divide that by our depth of field fall off value. So let's say that is for now 2. This just makes the transition between the minimum amount of blur, which is nothing, and the maximum amount of blur, which is going to be a parameter we add in a moment, just a little bit smoother depending on how high this value is. And then we clamp that value between 0 and our maximum depth of field blur. So let's set that to 10 for the time being. I'm going to save this and apply this just in case something goes wrong again. And then we put that into the size, and now we end up seeing things close to the camera are in focus and things further away are not quite in focus. So we have a depth of field. Now, most of these parameters I like setting to a parameter collection, just because there's only ever going to be one of these anyway, so I might as well sample it from a parameter collection. So what we do is we go into material and material parameter collection, and I'll just call this BC for parameter collection, DOF for depth of field. And all of these are just going to be scalar values. So let's add a couple of scalar values and give these some names. The first one is going to be focus distance. This most likely is just going to be the distance between the camera and the player, obviously. Then we add in our focus window size, our depth of field fall off, and our max blur size. We can also add a parameter here for the blur quality if we want to. Obviously, that is a thing that we could do. So let's set the max blur size by default to a value of like 8, and then our blur quality to 2. The fall off, we're gonna also do to the focus window. I'm gonna set to 500, and then this we can just give this a default value if we want to. Obviously, we're going to be setting this on tick through, for instance, the player or whatever. But let's give it a default value of 1000. Then we just go back into our material here, and we can get a collection parameter, and it already has our PC depth of field, and we just give in all those parameters that we made, like focus distance. And we just copy this node over. The second one is going to be our window size. And then we have our fall off, which is this one. And then we have our maximum size. So maximum blur size goes into there. And then we can make quality as well, which was this one. And we can put that into here too. And now we have everything hooked up to a material parameter collection. So if we now go into just as a showcase, the third person character, and we check, does it already have a tick event? It does now. We can set a parameter with set scalar parameter value, and then we take in our collection and we set our focus distance. And this is probably something that you do want to do on tick. You could technically do it on a timer. That is just super fast, but you probably want to update this every frame anyway. And then the distance is just going to be the get camera manager, get camera location. And the reason that we do this, by the way, instead of just using this camera, is if we have any different camera that we're looking through, this always updates from whatever actual position we're looking at the world through. So this is the most accurate way to do that. And then we just get the distance between that and get actor location. And we put that into here. Now we set up a simple post-processing volume. We make that unbound so that it extends infinitely. We add our material to that, post-processing material, add a new asset, add our depth of field. And you can see the fall off probably can use a little bit of work, to be honest with you. So it's a little not great. And here in the preview viewport, it all looks a little weird with the way that we have it set up, admittedly. But then if we actually play the game, you see that it all looks a lot better. So the player is in focus and there is unfocused outside of a certain window that we set up. And we can even, if I just tab over to my different window here, if I now set my focus window to be bigger, this should update, as you can see, in real time. And we can set this fall off to be smoother as well. If we increase this to like different values, the fall off becomes whatever we want. The max blur size, we can make that slower. We can make that much bigger if we want to as well. There is a maximum to the quality of it, obviously, if we only have a quality of 2. But if we increase the quality here, you can see it also does become a little bit better once again. So it's a balancing act between the size and the quality and everything like that. But we now have our custom depth of field, and you can iterate on this however you want, and you have this code now, and you can play around with what you want to do with this. And I just find that this offers more opportunity to be creative with than the built-in depth of field, even though, as stated before, it is going to be a bit more performance impactful, most likely. So just don't crank up the size and specifically the quality of this blur too much. Again, if you followed along and you want to just check out the finished project as we have it right here at this point, you can check out the download link for patrons and YouTube members down below this video. It helps support me making these videos, especially these longer, much like in-depth kind of niche videos. I really like making them, So some support goes a long way in helping me create more of this. And a very big thank you to all my Patreons. You can see them on screen right now. If you want to help support the channel or get any of the project files in any of my tutorials, there's a link down below to the Patreon page to support me, or alternatively as a YouTube member. My Cave Students tier supporters, Oiku, Earl, Nonseville Urno, and my Cave Digger tier supporters, Mauricio Farias.